I mentioned something earlier about carbon's unique ability to form rings and chains. And it's part of what makes carbon such a special element. It's a huge part of it. And it's a reason that there's an entire uh, branch of chemistry devoted to just carbon compounds. It's called organic chemistry. I'm sure you've heard about it. Nightmare stories from older brothers or sisters who've gone through it, and it is what it is. I mean, some people like it, some people hate it. Personally, I didn't think it was so bad. If you like puzzles, you like Orgo. But the idea, I think it's good, even if we can't get a really deep grasp on this, just to take a second to look at what we mean by this forming chains and rings. Here's a single carbon which can bond in all four directions. Right now, as that's drawn, the indication is that these would all be hydrogens around the outside. Now, assuming the last one, I don't put the hydrogen on there, say we do, say I swap that hydrogen and I move it off. And instead, we throw another carbon here. Well, we could continue to do this, and I can keep tacking on these carbons really indefinitely and adding these single carbon subunits. And what I'm doing, as you can see here, is I'm just making a chain and extending a chain. And I can go on and on and on. And this is how we build sugars, starches, fats. This is an example of carbon's ability to form chains. And then something even more complex than that, carbon can bond in multiple directions to form rings. And if we filled this out, we could do it again with just hydrogens, just with the dashes, so that carbon is bonded four ways. Each of the carbons are forming four bonds. This is an example of a ring, a carbon ring. So I just wanted to make sure that you had a picture of what we mean when we say carbon has the ability to form rings and chains. Now to focus on our last of the covalent bonds, which is called the triple bond. And a triple bond, illustrated right here, indicates now that we have two electrons being shared here, two electrons being shared here, and two electrons being shared there. There's our three shared pairs. The number of electron pairs being shared. And if it's three pairs, that means we have a total of 6 valence electrons being shared between these two carbons. Now, I'll do a couple examples of just specific Lewis dot diagrams for covalent compounds. I'll do the first two with you because I'm such a nice guy. We start with the Lewis dot structure for hydrogen, and it's 1 valence electron. Don't need to use X's. You can use all the same symbol at this point because we're not actually transferring. And our carbon with 7. And again, we said we're no longer going to transfer. Right? We're not going to do this anymore and trade ownership. What we're going to do now is pair them up. And we can condense this and clean it up just by showing the one dash line between hydrogen and chlorine, and make sure that you have enough electrons around each atom. In this case, I have 1, 2, 3, 4, 6, 7, 8 between or around the chlorine. And then for the hydrogen, it's just the shared pair that gives it the 2 electrons it needs to fill out its valence shell. Now we look at one of our diatomic elements. I'm going to have you draw the two ends side by side. We said earlier that the best way to do this is to keep the unpaired valence electrons between the two atoms. So that's what we're going to try to do. 1, 2, 3, 4, and there goes the 5th valence electron for nitrogen. Right next to it, 3, 4, and I'm going to put the fifth on the right. So that again, the three unpaired valence electrons for each nitrogen are between the two atoms. Let's say is you pair them up, pair them up, pair them up, and to clean this whole thing up, condense it, I draw 3 dashed lines between the nitrogens and put the lone pair to the left and to the right. So there's a lone pair around each nitrogen. If we count them up, that would be 1, 2, 4, 6, 8 around this nitrogen. 1, 2, 4, 6, 8 around this nitrogen. So they both have complete valence shells. That's how we check our work. So go ahead and complete the rest of these, and we'll look at the answers in class.